Hello, everyone. If you've ever shopped for internet service or tried to understand how networks actually work, you've probably come across these terms bandwidth and throughput. And honestly, most people think they mean the same thing. They hear their internet provider say 100 megabits per second and assume that's just how fast their internet is. But there's actually a pretty important difference between these two concepts, and understanding it can really help you make sense of why your internet sometimes feels slower than what you're paying for. So when you look at internet plans, you see numbers like 100 megabits per second, 500 megabits per second, maybe even a full gigabit. Those numbers are referring to bandwidth, and bandwidth is basically the maximum capacity of your network connection. Think of it as the width of a highway. A wider highway can fit more cars at the same time, right? Same idea with bandwidth. It tells you the maximum amount of data that can be transferred over your connection in 1 second. It's measured in bits per second, or BPS. So if you have a 100 megabit connection, that means in theory, 100 megabits of data can move through your connection every second. But notice I said in theory, because that's where throughput comes in. Throughput is the actual amount of data that gets transferred in real world conditions. It's not the theoretical maximum. It's what you're actually getting. So if bandwidth is the width of the highway, throughput is how many cars actually make it through in practice. Maybe there's traffic, maybe some lanes are closed, maybe there's construction. All those things affect how many cars actually get to their destination, even if the highway itself is wide enough to handle more. You can have a 500 megabit connection, but if you run a speed test, you might only see 400 megabits, or sometimes even less. That's your throughput. It's the real world performance, and there are tons of reasons why throughput is usually lower than bandwidth. Network congestion is a big one. If everyone in your neighborhood is streaming videos at the same time, your internet service provider's network gets crowded and your throughput drops. Hardware limitations matter too. If you're using an old router or an outdated Wi-Fi standard, that can bottleneck your connection. Even the website or server you're downloading from plays a role. If their server is slow or overloaded, your throughput will suffer no matter how much bandwidth you have. So bandwidth is what your internet service provider promises you. Throughput is what you actually experience. Bandwidth is the potential. Throughput is the reality. Another way to think about this is with a simple analogy. Imagine you've got a water pipe. The diameter of that pipe represents your bandwidth. A wider pipe can carry more water at once. But if there's debris in the pipe, or if the water pressure is low, or if there are leaks along the way, the actual amount of water that comes out the other end is going to be less than what the pipe could theoretically handle. That's throughput. It's what you end up with after all the real-world factors kick in. Or picture this. You're trying to fill up a swimming pool. You've got a big hose, which represents high bandwidths. In a perfect world, that hose could deliver a certain amount of water per minute. But if the water pressure is weak, or if someone else is using water in the house, or if there's a kink in the hose, the pool is going to fill up slower than expected. That slower rate is your throughput. One thing that confuses people is thinking that bandwidth and speed are the same thing. They're not. Bandwidth doesn't actually measure how fast data travels. Data moves at the speed of light through fiber optic cables, or close to it. Bandwidth measures how much data can be sent at once. It's volume, not velocity. So when your internet provider advertises a faster connection, they're really offering you more bandwidth, more capacity, more volume. And because you can send more data at the same time, it feels faster. A 500 megabit connection doesn't send data 5 times faster than a 100 megabit connection. It sends 5 times more data in the same amount of time. That's an important distinction. If you want to download a movie that's 4 gigabytes, a 100 megabit connection would take around 5.5 minutes in ideal conditions. A 500 megabit connection would take just over a minute. Same movie, same distance, same speed of light. But one connection can push more data through at once, so the download finishes faster. That's bandwidth at work. Now, there's one more term that often gets thrown into the mix, and that's latency. Latency is different from both bandwidth and throughput. Latency measures delay. Specifically, it's the time it takes for data to travel from the source to the destination. It's usually measured in milliseconds. If you send a request to a website, latency is how long it takes for that request to reach the server and for the server's response to come back to you. That round trip time is what we call latency. Latency doesn't really depend on bandwidth. You can have a super high bandwidth connection and still have high latency if the server you're connecting to is far away, or if there are a lot of hops between you and that server. Latency is more about distance and the route your data takes. If you're gaming online, latency matters a lot. You want low latency so your actions register quickly. High bandwidth helps with downloading large files, but it won't fix a laggy gaming experience if your latency is high. So just to recap, bandwidth is the maximum capacity of your connection. Throughput is the actual amount of data that gets through. And latency is the delay, the time it takes for data to travel. They're all related, but they measure different things. Why does this matter in everyday life? Because when you're shopping for internet, you need to understand what you're actually paying for. Internet providers advertise bandwidth. They'll tell you that you're getting 200 megabits per second or whatever, but that's just the ceiling. Your actual experience, your throughput might be lower. And if you're doing something that's sensitive to latency, like video calls or online gaming, having high bandwidth alone won't solve your problems. Also, most internet plans have asymmetric speeds. That means your download speed is much higher than your upload speed. If an internet provider advertises 100 megabits per second, they're talking about download. Your upload might only be 10 or 20 megabits. For most people, that's fine. Browsing the web, streaming videos, downloading files, all of that relies mostly on download speed. But if you're uploading large files to the cloud, or if you're a content creator uploading videos, or if you're streaming live on Twitch or YouTube, you need good upload speeds too. So pay attention to both numbers when you're comparing plans. Throughput can also vary depending on the time of day. If you're on a cable internet connection, you're probably sharing bandwidth with other people in your area. During peak hours, like evenings when everyone's home streaming Netflix, your throughput might drop even though your bandwidth hasn't changed. Your connection still has the same capacity, but that capacity is being shared among more users, so you get less of it. Your own home network matters too. If you got a dozen devices connected to your Wi-Fi, phones, tablets, laptops, smart TVs, security cameras, they're all competing for that bandwidth. Your internet plan might give you 500 megabits, but if 5 people are streaming video at the same time, each device is only going to get a fraction of that. Your router has to divide up the available bandwidth, and depending on how good your router is, that division might not be perfectly efficient. Older routers, or routers using outdated Wi-Fi standards, can really limit your throughput even if your internet plan is solid. There's also something called protocol overhead. When data is sent over the internet, it's not just the raw data. There's extra information attached to it. Headers, error checking, routing information. All of that takes up space. So even in a perfect scenario with no congestion, your throughput is going to be slightly less than your bandwidth because some of that capacity is used up by the overhead. It's not a huge difference, but it's there. Another factor is packet loss. Sometimes data packets get lost along the way and have to be resent. That slows things down and reduces throughput. Interference, especially on Wi-Fi, can cause packet loss. So can a weak signal. If you're far away from your router, or if there are walls or other obstacles in the way, your Wi-Fi signal weakens and your throughput drops. So what can you do to get your throughput closer to your bandwidth? A few things. First, use a wired connection when possible. Ethernet is almost always faster and more reliable than Wi-Fi. If you're doing something that needs a lot of bandwidth, like downloading a huge file or streaming in 4K, plug in with a cable if you can. Second, upgrade your router if it's old. Wi-Fi technology has improved a lot in recent years. If you're still using a router from 5 or 6 years ago, you're probably not getting the full speed of your internet plan. Third, reduce the number of devices using your network at the same time, or prioritize certain devices using quality of service settings in your router. And fourth, just be aware of peak usage times. If your internet is slow in the evening, that's probably congestion. There's not much you can do about it except upgrade to a higher bandwidth plan or shift your usage to off-peak hours if possible. Understanding the difference between bandwidth and throughput also helps you troubleshoot problems. If your internet feels slow, the first thing to do is run a speed test. There are tons of free speed test websites. They'll measure your download and upload throughput. If the numbers are way lower than what you're paying for, something's wrong. Maybe there's an issue with your provider's network. Maybe your router is acting up. Maybe there's interference, but at least you have a starting point. On the other hand, if your speed test shows that you're getting close to your advertised bandwidth, but your internet still feels slow, the problem might not be throughput. It could be latency, or it could be an issue with a specific website or service. One last thing worth mentioning is that bandwidth and throughput are relevant beyond just home internet. They apply to all kinds of networks. If you're working in IT or if you're setting up a network for a business, you need to think about these concepts. A company might have a high bandwidth connection between its office and a data center, but if there's a lot of traffic or if the network equipment can't handle the load, the actual throughput will be lower. Network engineers spend a lot of time trying to optimize throughput, reducing congestion, minimizing latency, and making sure that the available bandwidth is used as efficiently as possible. So to wrap this up, bandwidth is the maximum capacity of a network connection. It's what your internet provider sells you.